Wake up, wake up, wake up. You gotta get to math class. It's almost noon. Get out of bed. We gotta talk about surface area today. Oh boy, it's gonna be fun. But first, we gotta talk about yesterday's lesson. Get ready to hit pause, everybody, because yesterday I asked you to download some worksheets that look like this. First of all, I hope you took a close look at this and use this to answer your worksheets. That has a nice drawing of a lot of our prisms and pyramids, and even our cylinders, cones, spheres, half a sphere. Here is the answers to the Euler's formula sheet. Why don't you hit pause right now, take a look at those answers. And here's the answers to Who Am I? If you got that first page right, this one shouldn't have been too bad. Why don't you hit pause, take a look at that one. And finally, we also have to take a look at what we call nets, everybody. These are what we call nets. When we take a three-dimensional figure and we unfold it so it lies flat, it's called a net. And we're going to talk about some of those today as well. Are you ready? Okay, everybody. That was last night's homework. Now we got to talk about surface area. What is surface area? It's the sum of all the areas of all the surfaces. Well, it's a good thing you know how many faces are on some of our three-dimensional shapes, everybody. So, let's take, for example, this nice little tissue box. Imagine if I asked you to wrap this tissue box. Not nicely like your mom or dad would do, or Santa Claus, should I say. But if I said use the least amount of wrapping paper, you would then cut out 6 different pieces, wouldn't you, everybody, to wrap this. Now, notice, when we're looking at a rectangular prism, our opposite sides are exactly the same, aren't they, everybody? That means we can sometimes take some shortcuts. So I'm going to demonstrate some problems here. Sometimes using the shortcut, sometimes not. It's going to be up to you which method you want to use. But what we are going to be talking about, everybody, are shapes like our rectangular prism. This is also a pyramid, but what kind? Name for the shape of its base? That must be a square pyramid. So we can take three-dimensional figures like this, everybody, and we can unfold them. Imagine if I took this here rectangular prism and I unfolded it. Here's a rectangular prism, and if I was to unfold it, we now get that thing called a net. Again, please notice how these two are the exact same size. Like these two are the exact same size, and these two are the exact same size. Therefore, sometimes we can take a shortcut when we want to find the areas of all 6 of these rectangles. Well, we also took a look at our square pyramid. Here's a net for a square pyramid. Again, it's a pyramid, it's a square, and if I was to unfold it, it would look something just like this. Now, you can also take some shortcuts here too, can't you, everybody? Besides that one square in the middle, do you notice how all 4 of these triangles are exactly the same? We don't say the same in math. We say congruent. Yeah, so there's some more shortcuts we can take when we look at a shape like this. Once I find the area of one triangle, can I just multiply that by 4 since all 4 are the same? Or, of course, you could just find the area of all 4 individually. All right, everybody. Let's take a look at some examples for tonight's homework. Well, you're definitely going to need to know how to find the area of a rectangle. That's the length times width. You also have to be able to find the area of a triangle. That's 1/2 the base times the height. Let me demonstrate a couple problems for you here, everybody. And you guys got, I believe, 6 problems for homework tonight. 6. Uh-oh. Yeah, that means they're a little long. These problems take a little bit of time, but they're not really that hard. If you can find the area of one side, you just got to repeat it a whole bunch of times. Or not. All right, let's take a look at this one, everybody. Right here I have that's right, it's called a rectangular prism. And its dimensions are 2, 3, and 4 feet. Kind of easy numbers. Might not need a calculator for this, but again, you're more than welcome to use a calculator anytime you want for chapter 10. All right, let me demonstrate method number 1, everybody. I would say that I have 6 rectangles here. I have what I might want to call the top and the bottom, which are going to be the same, aren't they? I also have the left side, the right side, And I think I have a front and a back. And since they are all rectangles, I'm going to use the same formula, length times width. Well, I might not write that down 6 times because that's kind of an easy formula to remember, length times width. So let's take a look at this, everybody. They only put 3 numbers in here, so you have to move those numbers around. If the height of this is 4, then isn't the height for all these other guys going to be 4? You're more than welcome to write those in there, but it might make a little messier drawing. But again, feel free to write those in there if you want. I could say that's 4, I could say that's 4, I could say that's 4, and I can do that for all these dimensions. If this is 3, then that's a 3, and that's a 3, and that's a 3. I don't think I'm going to write all these down right now. That's going to make a mess of my drawing. But I do know that the top and bottom are congruent, the left and right side are congruent, front and back are congruent. So whatever I get for an answer for the top is going to be the same for the bottom. Well, let's take a look. The top and bottom must have dimensions of 3 and 2. That means 3 times 2, which is a 6. So the bottom has to also be a 6. Let's look at the left and right hand sides. They look like they're a 2 by 4. 2 by 4 is going to be an 8. That means this bottom one's going to be an 8. Let's take a look at the front and back. The front and back are going to be a 3 by 4, which is a 12, so the back is a 12. A nice little secret about finding surface area, everybody, is to remember that if I have 3 different numbers, I should have 3 different multiplication problems. If you don't, you duplicated something. You made a mistake. Go back and fix it. All right, well now, all I have to do is find the sum of all of these individual areas. All I have to do is add all these guys up. Well, I'm going to take a little shortcut here because I know a 12 and an 8 make a 20, and that makes a 20. So I got a 20 and another 20, that's 40, 46. I think I'm going to get 52 square feet. That's the surface area for this here shape, everybody. Let's real quick go over a little shortcut, another little shortcut you can make. If you take a look at your book, and I certainly hope you look at the examples and everybody, they're going to say the surface area is going to be equal to 2 times the length times the width, plus 2 times the length and the width, plus 2 times the length times the width. Well, that's because here's your top and bottom. That's why we're going to find 1 and double it. Same thing for our left side and right side. Same thing for our front and back. Once I find that one area, I just double it. So again, if I was going to call this the top and bottom, that'd be 2 times the 3 times 2. That's my top and bottom. Also, 2 times the length and width for, let's say, the left and right side. That was my 2 times 4. We also have 2 times the front and back, which is 3 times 4. Well, let's take a look. 6, 8, and 12. Well, that's going to make a 12, that's going to make a 16, and that's going to make a 24. Now I'm going to cheat with my calculator and say, well, what's 12 plus 16 plus 24? And of course I get the same answer, 52, don't forget your label, feet squared. Why is it squared? Because we're talking area. We're not in the volume yet. This is area. How many of these squares would fit on all the surfaces of this here rectangular prism? Let's take another look at a little more challenging example, everybody. Example 2, we now have a, what is it? Yeah, that looks like a triangular prism. The top and bottom bases are triangles, and the 3 lateral faces are all rectangles. That's a prism. Well, to find the surface area of this one, it's not quite as easy because not all these shapes are going to have a pair. So I think I am going to do all of these guys individually. Definitely tricky. Don't hesitate to write down what you think all these other numbers are, everybody. This, especially for one like this. Well, let's take a look here. I know I have a top and I have a bottom. Whoops, I'm going to keep those separate. I'm also going to have 3 lateral faces. That's going to be a little hard to write down. I might just call it side 1, side 2, and side 3. Let's take a look at what we have for all these, everybody. Well, my top and bottom, these are my trickier ones. These have to use the formula 1/2 the base times the height. Now, what's going to be really important is that you look for that right angle symbol there, everybody. That's going to tell you your base and height. They have to have that right angle symbol telling you that they are perpendicular. All right, well that tells me that I have a base of 5 and a height of 12. So 1/2 times the 5 times the 12. Well, half of 12 is 6, and 6 times 5 is 30. The top and bottom have to be congruent, so I know that the bottom is also going to be a 30. Now let's take a look at these 3 rectangular sides. These are all going to be length times width, length times width. Let's make sure I get all 3 of these correct. All right, I'm going to start with this easier one. This front rectangle to me looks like it's a 13 by 3. And 13 times 3 is 39. Let's take a look at this back rectangle. Maybe I'll call it back right. That looks like it's a 3 by 12, or 12 by 3, which is a 36. Now I just have to look at this left back rectangle, which looks to me like it's a 5 by 3. And 5 by 3 is a 15. Now, we're just going to add all these guys up, everybody. Let's see what we're going to get. Compatible numbers tell me I got a 15. That makes 20. Now I got 2, 5, 8, 11, 14, 15. 150 inches squared for this here triangular prism. Please, everybody, take a look at the book. Look back at the examples. They really show you lots of nice ways of doing it. You got 5 problems to do for homework tonight. Here they are on page 413. You're going to do 7, 8, 9, 10, 11, and 15. Please show your work. Thank you, everybody.